The final example for this chapter is example 5. Here we take a random sample of 500 apples, which yields an X bar of 9.2 ounces, and we know the standard deviation is 1.1 ounces. So we're going to start with our statistic of 9.2, and we're going to figure out how much error there is in the statistic. And for some reason we're estimating the weight of mean apples. Don't ask me why, but that's what the problem says. So the error tolerance here is the same as in the last example. It's z times sigma over square root of n, because we're estimating the mean. So the way you determine what error tolerance you're calculating is based on whether you're estimating a mean or a proportion. In this case, we want a 95% confidence interval, which means z is 1.96. Standard deviation is given to us at 1.1, and we know the sample size in this case is we have 500 apples. So if you crank out the math here, this will give you 0.096. So then we can take our point estimate x bar and we can add and subtract this 0.096 or this error tolerance. So we take 9.2 plus or minus 0.096. So 9.2 minus 0.096 and 9.2 plus 0.096. That gives us our interval of 9.104 to 9.296 ounces. So therefore, we are 95% confident the population mean weight of apples is between 9.104 and 9.296. And you'll notice I write these confidence statements basically the same every time, and I'm pretty consistent with that. You don't have to write them exactly as I write them, but you do have to make sure they include the main parts: the confidence level, the parameter that they're estimating, in this case the mean weight of apples, and then the interval itself.